asymptotes. Remember we said a vertical asymptote is x equals whatever makes the bottom 0. Horizontal, we had when the degree on the top was smaller, it was always y equals 0. If they had the same degree, we divided leading coefficients. And then oblique happened when the degree on the top was 1 bigger. You guys had that math Excel assignment. It's obviously due at the end of the day today, and then after that you get late credit if you didn't get it done. Today we are going to start drawing the full graph for these rational functions. And so we're starting off, the first thing I have up here, these are the steps that we're going to go through when we graph a rational function. You don't have to necessarily memorize the steps. You know, on the homework I'm just going to say graph them, and I'm going to expect you to do all these. On a test or quiz, I would break it into an A, B, C, D question and remind you of each piece along the way. But the first thing we're going to do is factor. We're going to look at the top and bottom of the fraction and see if we can break anything down. Write it in lowest terms means if anything cancels, we want to go ahead and do that. We're going to make our problem as simple as we can from the beginning. Step 3, intercepts we've talked about with lines. We touched on Friday with these rational x and y intercepts. Basically that's just plugging in 0 for the opposite variable. Vertical asymptotes, we were doing x equals whatever makes the bottom 0. Step 5, horizontal or oblique, we said you'll never have both. It's one or the other. And then we will put all that information together to draw the graph. So make sure you have these steps written down. On your homework tonight, I will expect all of those steps to be done. I want to talk about one other thing that sometimes happens, and that's a hole in our graph. A hole is just an empty circle along the way. And that happens whenever you have something that appears in both the numerator and denominator. So to find it, we'll plug x into the remaining equation and plot as an ordered pair. Okay, so really it probably makes the most sense if we just look at an example. If I have x squared minus 9 over x plus 3, what could you do to the top?
X plus 3x minus 3.
Now we have an x plus 3 on the top and bottom, so those cancel out. When something cancels like that, that puts a hole in the graph. We're going to give the ordered pair for that hole. The x value is what would make x plus 3 equal 0. Okay. To find the y, you plug negative 3 into what's left. So we set the x plus 3 equal to 0, and that gave us the x is negative 3. To get the y, you plug a negative 3 in here, so negative 3 minus 3 is negative 6. So when I graph this line, it would just be an open circle here. Otherwise this is a line, y-intercept negative 3, so the actual graph looks like that. We will talk more about those as we come to examples that have this. But I just wanted to touch on it here. So now for the rest of the day, we're just going to do examples. Here is the first one. All right, first step is to factor everything that we can. So negative 1, that doesn't Nothing happens there. What about the denominator? What multiplies to 4 and adds to 4?
X plus 2 and x plus 2.
You could also write that as -1 over x plus 2 squared. Either way is fine. Okay, the second step we put to reduce, but does anything cancel here? No. So this is in lowest terms already. Next, we have to do intercepts. Bless you. So x-intercept. That's when y equals 0. So if you plug in a 0 for your r, the first thing you're going to do is multiply over the denominator. But 0 times anything is still
0.
So you get 0 equals -1. Can that happen? No. So there is none. The x-intercept, it's really just what makes the top of the fraction equal 0. To get your y-intercept, you plug a 0 in for all of your x's. And I get a -1/4. If you wanted, you could go ahead and plot that. We're going to hit the x-axis, or the y-axis at -1/4. We're never going to touch the x-axis. Then we go into asymptotes. So vertical asymptote, x equals whatever makes the bottom 0. What would that be? If you set x plus 2 equals 0, you just get a -2. Multiplicity doesn't matter. It doesn't matter that there's 2 of them. So if I want to graph that, it means at -2, we draw asymptotes just as dashed lines. Okay, next step is either horizontal or oblique asymptotes. Remember, those are based off the degree. What's the degree of the top here? None. Yeah, it's like how many variables you have. We have no x's on top. What about the bottom? 2. Anytime the top is smaller, we are doing Friday, it's a horizontal, y equals 0. Y equals 0 is just the x-axis. That's why I didn't have an x-intercept. It's an asymptote here. And we know that if there is a horizontal, there is no oblique. Okay, so the expectation. I will ask for each of these steps. Okay, test or quiz, I'm going to say step A, factor it. Write it in lowest terms. Step B, give me the intercepts. Now, I'll ask all those questions. I expect you to plot everything you find on your graph. So no guessing where you hit the y-axis. We know where it is. Put your asymptotes exactly. Then we just need to sketch in the graph. So you can use your graphing calculator to kind of help you get that shape. So if you would, get out your calculator. I'd recommend graphing the original. So that was -1 over, put the denominator in parentheses. So x squared plus 4x plus 4. Okay, so our calculator on the Chromebook, it does not draw in the asymptotes for you. But we can see, we know where it's happening. So these dashed lines, we're not crossing them. When you draw your graph, it should be approaching them. If you draw me a graph like this, I'm going to count off. Okay, you can put a little more effort into it. It doesn't have to be precise, but you need to draw it. It's getting closer to these asymptotes as time goes on. Okay, so this is just getting closer. It's getting closer here. This one, make sure you go through your y-intercept. So your calculator basically tells you were you above or below this horizontal asymptote. And when you sketch that in, make sure you're going through any intercepts you have and that your graph is approaching your asymptotes as time goes on. Any questions there? We're just going to keep trying these. So second one, x squared minus 4 over x squared. So the first step is just to factor. X squared minus 4, how would you break that down? X squared, there's really nothing you can do. You can write it as x times x, but that's certainly not necessary. You can just leave that as an x squared. Cancel out anything that we can. Things are only going to cancel if you have the exact same factor on top and bottom. So if I have an x plus 2 on the top and an x plus 2 on the bottom, they drop. Here, nothing drops out, so we're going to go straight into our intercepts. Yes?
This might be a stupid question, but at the very, very beginning, why couldn't you just
Cancel the x.
cancel the x squares?
You can cancel when things are multiplied, not when they're added and subtracted. So because this x squared is subtracted with the 4, we can't cancel them. If it was written like a 4x squared, then you could because they're multiplied together. Good question. Alright, x-intercept is when you set the entire thing equal to 0. The first thing you're going to do though is multiply over your denominator. And anything times 0 is still 0. So it's really just what makes the top 0. So what do we get?
X equals -2.
These are intercepts, not asymptotes. So we just plot those as dots. We hit the x-axis at a positive 2 and at a negative 2. Y-intercept is when you make your x's 0. You can do the original, you can do your factored, it doesn't matter a bit. But if I get 0 on the bottom, can we do that? No. So there is none. We're never going to hit the y-axis here. Vertical asymptotes. Remember, asymptotes are lines, so I need a full equation. Vertical is x equals, what will make the bottom of this fraction 0? So when x squared equals 0, it's just 0. So vertical at x equals 0, that's just the y-axis here. Okay, we have to decide horizontal or oblique. So we base that off the degree. Degree of the top here is bottom.
2.
If it's the same degree, we divide the leading coefficients. So this is horizontal. Y equals 1 over 1 is just 1. And then of course if we have a horizontal, there is no oblique. Then we just use our graph to fill in the blanks here. Make sure you put, I always do the original, that way if I made a mistake I can catch it. Do parentheses on the top and the bottom. I have x squared minus 4 over x squared. And again, we see both of these curves are below that horizontal asymptote. You have to know I'm going through your intercept, getting closer to the asymptote as time goes on. Questions on that one? Oblique happens when the degree on the top is one bigger. So horizontal, those were the rules from Friday. If the degree on top is smaller or the same, we get a horizontal. I want you guys to try one. Get as far as you can. So do the steps, factor, intercepts, asymptotes, all of that. So the factoring part looked like everybody did fine with. X minus 1, nothing you can do with that. X squared minus 4 breaks into x plus 2, x minus 4. Second step, the x-intercepts. Okay, that's when your y equals 0. The first thing you would do if you were solving this is multiply over the bottom. But when I take 0 times the bottom of this fraction, what do I get? 0. So when you multiply over the bottom, an x-intercept, all you really have to do is set the top of the fraction equal to 0. So we just get x equals 1. So x-intercept is what makes the numerator, the top of the fraction, equal to 0. Y-intercept, you plug in a 0 for all of your x's. So 0 minus 1 is negative 1. 0 plus 2 is 2. 0 minus 2 is negative 2. So I get a positive 1/4. Vertical asymptote. So this is from Friday, our asymptote rules. It's x equals whatever makes the bottom 0. That's why we factor it. So it's easy to look at and tell what would give us a 0. So what would make x plus 2 equal 0? And x minus 2. So we have two of them, negative 2 and positive 2. Okay, now we decide horizontal or oblique, and that's based off the degree. You can look at the original or your factored one, it doesn't matter. The degree of the top was 1, the bottom is 2. Anytime the top has a smaller degree, it is a horizontal, y equals 0. That was a rule from Friday. Now it may seem kind of weird because I do actually have a point on that, but if you remember, I said sometimes you might cross a horizontal asymptote in the middle, not the ends, but you might go through it in the middle, so that's okay. Now we're going to graph this. I always recommend using the original, and make sure you do parentheses around the numerator and denominator. So we get x minus 1 over x squared minus 4. So I can see this first piece is below the asymptote. Then I have kind of that one and then another piece above. So, draw on your curves, approaching your asymptote, so you're down below. The middle one started up high, came down, hit your intercepts. And the third piece was above. Any questions on that? Let's do one more example and then I'm done for today. So last example. X squared minus 1 over x. Okay, so first step, factoring. X squared minus 1, difference of squares breaks into x plus 1, x minus 1. Down the bottom is just an x. B, x-intercept is when y equals 0, and I told you that's really just when the top of the fraction equals 0, because you would just multiply over your x and it cancels. What makes the top equal 0? Y-intercept. If I plug in a 0 for all of my x's, you can do the factored or the original. If I just go to the original, I get 0 minus 1, so negative 1 over 0. Can we do that? No, so there is none. Vertical asymptote, x equals whatever makes the bottom 0, which is just a 0. X equals 0, that's just your y-axis. Now we decide horizontal or oblique. So what's the degree of the top? 2, and the bottom? Remember, if the top is 1 bigger, that's oblique. So we're looking for a line, y equals mx plus b. Remember, to find oblique, we did long division. The x went on the outside, inside was the numerator. I'm going to put in a 0x just to help me. Okay, we don't have to do the full long division. We just need to get the equation of this line. So you divide the first terms. X squared divided by x is x. Bless you. Multiply, x times x is x squared. If we subtract that off, those cancel. Bring down your next term, we have a 0x. What is 0x divided by x? 0. So we just get x plus 0, which we don't even really need the 0. It's just y equals x. This is just a line. So you start at your y-intercept, which is 0. Slope is 1, so up 1 over 1. So back to algebra 1, graphing lines. Plot your y-intercept first and then do rise over run. I'm using the calculator. We have x squared minus 1 over x. So what's happening is the first piece is over here, second one down here. Make sure you go through your intercepts get closer to your asymptote.